Hello, everyone. I'm very pleased to be talking for BIM Harambee Africa today. I will introduce myself and explain what this presentation will be about. It's about open standards, and I will explain to you further on how I see things around open standards. Some words about myself. My name is Julien Benoit. I'm French. I've been working for around 25 years in the construction industry in various places, mostly in France. I started my career as a site foreman, and then I've been changing companies, being a construction engineer, and finally I was introduced to BIM and turned myself into a BIM specialist and then BIM manager in different companies. Most of my career has been in large organization, I would say, international companies like Bouygues, Vinci, Legendre. I started my journey around BIM in 2008 with embracing first the tool, the authoring tool, and then I got really addicted to it and wanted to do more around these tools, and just not using tools, but also implementing workflow and all that. I can share some about the most exciting times I had around BIM in my career. I think the first one was to be involved on the construction on the new subway line in Rennes for Groupe Legendre. And it's been really challenging. It's been really interesting because it was really a start of my professional career around BIM. Also, the next step was, and the next really exciting time I had was transforming the technical department inside Legendre for going from CAD only to BIM only workflows. And it's been a journey around 5 years, and it's still ongoing because it's never done in a way, but it's been really, really exciting for me to be able to accompany these people. And the last one I can talk about around this BIM journey is joining Catenda, a company located in Norway, providing a tool called BIMsync that is a collaboration platform available online as a SaaS software, 100% based on open standards. So that's my current position. I'm head of customer success in this company, and I'm recording this video from Norway today in Oslo. That's where I live nowadays. So now some words about this presentation as an introduction. I want to discuss today open standards in the construction industry, why I feel it's really important to know what they are, what they're used for, and what they can become in the future. I also want to have a short discussion about standard as a word and as a meaning, what it means, what it is, and why we are using them, with some example. Some words also about the setup. As you can see, it's challenging times. Usually I did some presentation earlier in time in front of people, in front of a crowd, and you can interact with people, you can look into their eyes, you can communicate even silently with your attendees. It's not possible today. I will do my best to actually look into the camera so my eyes can be straight to you, but it's really challenging. It's difficult to do. So I will make some short clips and put them all together so it gives you a better experience. And on some part of this presentation, I will have to read a script I made, so you will see my look will be shifting from places to places. I know it's not the best, it's not ideal. I would be rather in front of you talking and discussing and even interacting with you, but that's how it is. Pandemic times, challenging times. So this is the setup for today. Forgive me in advance for some language mistakes. Obviously, I'm French. English is not my native language, so sometimes I slip and forget some words. So get obsessed by that, or don't get upset, I would say. Also, this presentation will be around 45 minutes. I know it's also a challenge. You probably look at a lot of videos online on YouTube and all that, and I do myself, and I see that 45 minutes can be a rather long video to watch. So I will try to make it as pleasant as possible. So a discussion about standards and open standards, what they are. To me, a standard is a common area. It's a place where we can share most of the knowledge and information we have. A standard means that we can share most of the information, and at least the relevant one, without sharing 100% of the same knowledge. One technician can share information with another one, even from different fields, without having the need to know exactly all what the other guy knows. A standard that we all use every day, or standards that we all use every day. There are several, but I want to emphasize 3 of them. The first one is time. It sounds a bit obvious nowadays, but it hasn't been always like that. Now we have universal time that is properly defined, and it's well known, and we all use it without even noticing it. But it's been different because this has been set early in the 19th century, late in the 19th century, sorry, and it's been mostly because of a new technology adoption, and it was train travel. Before that time, people used to set local times based on the sun. And once the train travel became more and more popular, it's been a necessity to coordinate time zones and time between the departure and the arrival of the train. So that's why people came with a solution for that. And it's a standard, and nowadays we use it every day without even knowing it's a standard. But it was not obvious at first. Another one we can discuss about is the unit system, units. And it's there's a system called International Standard Units, or units in international units. And it hasn't been always like that. And you can even argue that nowadays some countries are still using imperial units. Yes, that's true. That's their choice. But you have to know, and I wasn't aware of this before I checked myself, that these units are also defined on the standard international units. So a feet and inch is defined by a set and an amount of millimeters. So that's a standard that we all need, use, and that's also one of the first standards what we use in the construction industry. The third one I can kind of emphasize is also the language. I'm speaking to you in English now. It's not my native language. It's probably not yours. And it won't be the perfect one. For me, I have a knowledge in English, but I'm not perfect, far from it. So I use it as a standard, so I can share with you most of the meaning I want to express, of the words I want to tell you, even though I can't maybe express 100% of what I want to say. You get the full picture, and it's the same for you in your own language. So this is to me, what defines a language. It's either a need for us as human beings to communicate, so it's the language, and it's also comes from technology adoption. Some technologies are making a revolution in some area, and then we need to embrace and adopt a standard so we can work together around these technologies. And now it's the construction. So I can share with you some words and thoughts around construction standards and the way things used to be done before BIM, in the BB times, before BIM times. And it's a bit making shortcuts and all. It's not totally defined, but you will get the picture. So for instance, when you think about it, and there's some great books out there about these times, medieval times, when you wanted to build large buildings, churches, cathedral, and all that, the only way to do that is that you were to send human beings on the construction site. You were to send the architect. So this guy, having this knowledge, would be able to express what was needed to the craftsmen on site and express what it. So he had some sketches, he had some paperwork, but still, most of the knowledge to transfer from his brain to the site and to put into action was via human beings. He had to be there. In the modern times, you were set to send drawings printed on paper, so you can transmit your knowledge and your view on the design via a media. The media was a set of drawings on paper. And then with the adoption of new technologies, computers, all that turned into digital drawings. So we were able to send digital drawing, not only printed drawings. And of course, this changes from sending a human being to sending drawings on paper, then digital drawings allowed us to make more people collaborate together and share knowledge. So then we had the better construction techniques, because there was an engineer for the structural part, there was an engineer for the plumbing and heating, and there was also an architect for the design and all that. So we kind of expanded the field of the construction industry by having media to share knowledge of people. And in these times where we were able to send digital drawings, all of a sudden, the PDF format became a standard. It was not willingly, but it's how it is. People embraced this format as ND1, good enough, not perfect, but most of the information went through via this format. A bit further on, with some people tried to get some new digital drawings that you can reuse and modify, and then DWG format became almost a standard. We all had this experience of getting DWGs from an external consultant or other parties on the construction site and just get, it's all crap, I have to do it all over again. But still, it's been, and it still is, kind of a standard, but it's like not standard by necessity. It was not, we didn't decide on DWG to be a format that is a standard. It turned out to be that way. And also keep in mind, and that's something I'd like to emphasize at least and make you think about it, is that neither PDF or DVD is an open standard. These are proprietary formats from companies that could have decided at some point to just shut it down. It happened before. Some companies disappear with their standard. So that's also why it's important to have open standards. So it's really the industry that owns the standard and not only a single commercial company. So talking about standards and open standards owned by the industry, here is the Building Smart International. That's the group of people, the organization that defines open standards today for the construction industry. And these standards being mostly IFC and BCF. I will talk a bit further on about this later on. So this organization, the good part of it is that everyone can be involved. You are allowed to subscribe and accompany this group of people to get your hands on the standards and improve them. You own these standards as well as the others, so you can make them better. As I discussed before, a standard is not meant to be perfect. No, it won't be. It will never be perfect. It's a compromise. It will be only compromises. It will be discussions, what people want, what they don't want, what they like, what they don't like. So it will be the best combination of compromises you can get, so you can transfer your information and your knowledge. That's the purpose of such standards. So you will find a lot of information online about Building Smart International. You can subscribe and be part of this community, and I will just share some of the different chapters. If I can get just to get to, here we go. So as you can see, Building Smart International is divided into different chapters, and these chapters are localized all around the world. So I will just scroll down all these groups of people that internationally are discussing improvements, modification, changes, so these standards we're talking about can get better and better and better along the way. So as you can see, it's like the planet almost is discussing around this. And that's very exciting and very great news to see how many people are involved. But of course, the challenge is also here. As you can see, as everyone is involved, it's not everyone that will agree on some stuff. So it will be compromising. And the downside of it is that it's a slow process. It takes time to evolve. It takes time to change. But I believe that's for the greater good. It will be better that way. So because the compromise will be industry adoption. So among the standards that Building Smart International is defining and promoting, I will underline 4 of them and also share my thoughts around the 2 main adopted ones that are IFC and BCF. So the first one is the IFC standard, IFC file format. It's set for industry foundation classes. And I won't discuss in details what it is, but it's a way to organize all the parts and the elements of a building into a proper set of data and database in a way. So what you do without knowing it, when you use IFC format, you are organizing your design and your construction project into a properly defined database. Not the best one for many reasons, but still, you don't know it, but you're building your own database. And that's very important for the future use of these files and of this format. The next important format, and I will show you the importance of it in a future example, is the BCF format, Beam Collaboration Format. It is set to allow people to discuss and communicate around models. And that's a challenge because you need to be able to share point of views and extract of the models and part of the models around 3D mockups and all that. So it's a challenging one, but it's widely embraced now by the industry, the software providers, and it's fully documented. So that's also an important part of the standards. It's like anyone can just get at the table, have an opinion, try to improve it, make it better, make it more efficient, and so forth. 2 other standards are defined by Building Smart International. A bit more on the side at the moment. I don't see that much embraced in the industry right now, adopted in the industry, but I know it's coming. It will take time because there's a huge value in it. First one will be Information Delivery Manual. So again, you will find online a lot of information, detailed information about that, but it's about the methodology you will have to put in place so you can work with these standards from the very beginning of the project and for the whole life cycle. The last one is called the MVD format, Model View Definitions. So it's again a standard so we can share the same definition of what a model is and what you see on such delivery and what you see on subpart and so forth. and all it's combined. So IFC is the ground for the MVD views and etc. etc. So I won't get into details, and I'm not. I don't know everything around these standards. I know some, but not everything. So let's. I leave it to you to elaborate and to see more around these standards. What is really important today, and because it's the state of the art in the industry, I believe, is the BCF format for collaboration and communication, and to share your data and to share your design and share your information. It's the IFC format. That's really, really widely adopted in the construction industry nowadays. And these standards will continuously evolve. You had the 2x2, 2x3 format. IFC4 is getting more and more popular nowadays, and it will be 4.2, 4.3. Finally, there will be IFC5, etc., etc. So it's a continuous process of improving the standards for embracing new technologies, new ways of building, etc., etc., etc. So it's very promising to believe in this standard. Here we go. Now I'm sharing my screen with you, and I will discuss and explain a bit about a project that happened in France in Rennes some years ago, and this has been a great success for the companies building it and owning it nowadays. And now I want to emphasize and explain how it's been done around BIM and why on this kind of project open standards have been mandatory. So this project takes place near the railway station in Rennes, in French Brittany. And it's composed of 3 office buildings on top of a large parking lot dedicated to the train station. So it's around 24,000 square meters, which means each building is around 8,000 each. And it's been developed and by a French group called Giboire for around 75 million euros. And for the sake of the right properties, here are the credits for the architects. It's 3 architect teams that developed the project. If you want to get more intel on this very project, you can search on Google with the keywords identity Rennes, and you will find a bunch of great pictures showing different states of the construction sites and so forth. So you can find a lot of details online on how it's been said. There have been some articles in the specialized press around technical details and all that jazz. So you can find a lot of references around this project. So now what I want to share with you is how it's been designed and assembled. So it's been from early days of this tender admitted by the teams that according to the shapes and the design of these buildings, there was really no way to avoid BIM as a workflow on this project. Drawings were simply not enough to describe the geometries. So it's been an agreement that we need to have a place to share models, and we need to issue and combine models all together. So, and according to the variety of contractors and subcontractors in this project, the only way this can happen was via IFC format, an open standard. So that's what happened. So let me guide you a bit through this design, through these models, so you can grasp the technical challenges, the difficulties, and where IFC were really helpful to be able to assemble a wide range of models and different sources of software, authoring softwares and all that. So I will start with one of these buildings, and I will strip it down in a way so you can see how much models it has been consistent of, and explain also a bit what's been done on the project. So you can see here that this is a focus on the number 2, the building number 2. So this is number 1, number 2, and number 3 in the back. So I will focus on this one for now and show you different aspects of it. So as you can see, it's also been assembled with the site installation for better understanding of health and safety on site and security assessment. So it was kind of needed to have this in place. So there's a lot of nice detail in this model, including the site installation, formwork, storage area, trucks, and all that. So it's kind of cool to see an advanced project like that, a detailed project like that. So let me show you a bit more about this very building, number 2. So I will just remove from the viewer some of the unnecessary models. So I will remove the parking lot, I will remove the installations on site, and the mock-ups for the 2 different buildings. So here we go. We have only one building now. So the shape, the strange colored shape you see, was issued by the architect as the global or the overall shape you shouldn't go through in a way, like the concept shape you need to follow. Now, stripping it down, you will discover how it's done. So this is called the envelope, so the overall shell of the building. And as you can see, the shapes are a bit crazy. It's like it's supposed to represent a broken stone, like a stone that's been broken into 3 parts. So this is one of the parts of the stone. So you have tilted walls, tilted facade, straight facade, and all that. So there's a lot of details here, interesting details. And it's also the composition of the facade itself is also complex with many layers. I will zoom in, a bit, and you will see the level of detail achieved by these models. And as you can see, it's a building model. It's really what's been put into place by the subcontractors and the contractors. So you can see the supports for the framing system, and you can see, how detailed these models are. It's not perfect, could be better, but for the time, it's been like 3 years ago. It was just quite impressive. So now I will just give you a closer look on how it's been assembled together by removing one by one some of the models. So this one, for instance, is like the overall shell, and now you can get a grasp on how detailed this project is. So you see there's a steel framing involved with these elements coming from Tekla structure. These elements are wooden framing elements coming from CADWorks software. And the rest is assembled on top of concrete structure that was modeled in Revit. So this is for the structural part, and all these elements have been put together in this model so we can actually have a proper coordination, because you see from these crazy angles and crazy shapes, there's no way one can achieve proper coordination of this without models. You could try with drawings, but it will fail at some point, because it's been basically designed by a software that is available and can achieve these kind of shapes. So once the design started in a authoring tool that is able to deliver such shapes, you need to follow up and you need to do the same with the construction phase. So let's strip it down a bit more. I will remove some of the facade. So you see the wood is going now, the structural framing, like the steel framing, and you can see now there's mostly the concrete that is left. There's some specific part here, like this staircase is in steel, so I will move that as well. And then it will be left with the concrete structure and all the MEP networks and installations. And this is also part of the challenge of doing proper coordination, is that you need to have almost everything modeled. Everything that takes space in the building needs to be modeled and assembled in a model, so you can actually coordinate all that. And again, all this has been issued via the IFC format, because I will remove some of this so you can have a glance on how difficult and detailed it is. That's the level of detail we got to on this model, so on this project. So maybe it's too much, maybe it's not enough, I don't know, I can't tell really. But what I know is that without a proper standard to share this information and assemble it together in such a platform, for instance, no way we do that without an open standard. So everyone was able, every subcontractor was allowed to use whatever authoring software they wanted, but it was mandatory to issue, along with their drawings and detailed descriptions and all that, it was mandatory they issue one or several IFC files in the 2x3 format at the time. And this is what you have in front of you now. This is the result, and it really was successful. And the team, the construction site team, the site managers were not really convinced at the beginning because they thought it was a lot of extra efforts to put in. But look at the details here. You see this concrete part has been, in this concrete part, 3 holes have been set into place because this is cast in place concrete. This concrete has been poured in place. So you see the result of a perfect or close to perfect coordination on this construction site. You see in the model how precise and accurate it is, because that's been really well done at the time by some of my previous colleagues. I can show you another example I saved earlier, and this example is here. So you see how important it is to have proper models assembled together for proper coordination. So you don't have to crush concrete on site or drill a specific hole that is noisy and costly. Just set the design and coordinate it correctly first, and that will be good for you. So another great use of these open standards on this project was not only to assemble together and coordinate the things so you can actually build it on site, but it was also to define and design the final pieces and assemblies. So it's this example here. It's been a digital mock-up that was achieved prior to the construction phase with open standard, because there are like 4 or 5 people designing together some piece of it, so it can be validated by the architect and the checkers and quality checkers and all that before we start to build the entire building. So if I show you the amount of detail, so you can see that the shapes are a bit crazy, and it's a challenge to achieve this. So you see there's a complex framing here that is holding together a shell and is holding together another one, etc., etc., etc. So I can't explain all the details here involved, but this is this kind of digital mock-up that was at the very start of the construction process to validate the choices, the material, the thickness, the way you fix things together, the way you assemble things together. And it was only possible because everyone was using the same file format, the IFC format. Also, it was not only about models, it was also about collaboration. And on the last example I will use on this project, it's about coordination. How will you achieve proper coordination and communication with open standards? So again, I will focus on a different building, the number 3, identity number 3 on this one. I will remove some of the unnecessary models here, so we can have a look at this one, a closer look at this one. And I will also strip it down a bit so you can see what's going on behind it. Again, you will I don't have to comment on this. You will see it's a complex building. A lot of things is happening in the back. There's different layers on the facade with different type of framing and steel framing involved. And of course, it's a modern office building, so a lot of networks inside, ventilation, heating, plumbing, and all that. So a way to ensure that everyone can access the proper communication around coordination, and so you don't have to send too much documents, emails or other ways. There's another standard that's been used intensively on this project. It's called, and I talked about this earlier, it's called the BCF format, BIM collaboration format. So what it does is that you raise an issue, you raise a problem because someone is looking into details and sees that there's a coordination issue at some place. For instance, on the 7th floor, there's a MEP stuff that's not right. So you can zoom and see a snapshot. So you see here this pipe is having an interference with the structural beam, concrete beam. So the person in charge of coordination set an issue out of this clash, you would call it a clash, and assigned it to a team, which is the guys in charge of the ventilation here in this plumbing and ventilation. In that case, with a tag for the floor and a tag for the trade, with due date and all that, so you can actually monitor and follow up on the trouble you saw. So people will be assigned this issue and will check it online and we'll see, oh, I'm in charge of this, so I need to do something. So they will be able to look at the issue and they will also be able to recreate this point of view. And that's the power of this BCF format. Because you're not only saving data like names, teams, and status and all that, you're also saving viewpoints and elements so you can see them in the model at the same time you click on this little play button. So you see previously the pipe was going through and having interference, and now in the updated model, as you can see on the right, this pipe has been changed, so now it's clear under the beam. Done. So now you see that this issue is closed. And it's been really a journey because of, again, it was like early days in a way, and it was not mandatory at the time to collaborate this way, but it's been proven really, really successful on this project. And everyone involved in this coordination process and the site manager also definitely agreed at the end that the next project they will have to do this way. They want to use open standards. They want to use IFC. They want to use BCF to collaborate on such a large project. So this is the last part of this presentation. I'd like to discuss a bit about the future and the possibilities of open standards in the construction industry. To me, the different areas I see improvements will be that first, there will be no discussion around open standards as they are, IFC, BCF, MVD, that the entire industry will acknowledge that that's the way to go. I'm not sure it's the case today, even though it looks like it, but I really like to see it as rock solid standards for the industry with a wider adoption for every software around the planet, around industry, construction industry, being able to deliver proper IFC files, maybe in a different way, maybe it has to change. Yes, there are things that needs to change, but this will come for sure. And with a wider adoption, I also believe that if the user base gets very strong and with the commitment of large organizations, software authoring tool companies, yes, but not only, also construction companies, developers, owners, all these people together, if they come to embrace and improve and participate into defining the open standards, the industry will own it and will own the standards they are using. So that's the only way we can develop, in my opinion, a strong and solid construction industry for everyone to be able to participate. We need to define these standards for ourselves, not only for the sake of some commercial companies. We need these companies. I love these companies, but still, if we wanted to make to be very valuable for everyone, it's only if the industry embrace it and owns it. So let's own our standards. Let owns the open standards. And also, I see a trend, and I don't want to share some names because I'm not fully aware of what's happening, but I see also very exciting times for new authoring tools. One being FreeCAD and some others around the planet that really are starting to embrace seriously the IFC format. And to me, that's a great sign that, yeah, okay, if you're not able to afford expensive softwares, there will be a solution for you, no matter what, to be not to be left aside with this technology adoption. So that's also very exciting, and I really look forward to see improvement in this field, so we can promote the use of IFCs and all these standards for the construction industry without having to spend money you can't afford. That just, and it will also help to put at the table small companies, small businesses that are nowadays complaining about BIM as being an expense more than an investment. And sometimes it's right, but I think if we can develop and support more and more the open standards for the construction industry, I think it's very, it's a democratic tool to share around and to let people get at the table with us for the greater good of the construction industry. So that's it for me. I hope you enjoyed my discussion, and that I raised some questions for you, some integrations, maybe some discussions to have with your colleagues. So I'm really pleased to have this discussion with you here. I hope you enjoyed it, and have a good day.